So today we're going to talk about the calculation of sine and cosine of 15 degrees. All right. So we're going to introduce a few methods to calculate the values. Of course, before we start, it's a good idea to review some of the special angles. For example, 45 and 30 and 60. Now, of course, this is a very familiar figure where I have 45 degrees. This is a right angle. And then according to the definition of a sine, which is 1 divided by square root of 2, and cosine in this case is the same as the sine. So it's 1 over square root of 2, or if you multiply square root of 2, both the denominator and the divisor here, you're gonna get square root of 2 over 2. All right. So that is the sine and cosine of 45 degrees. Another special angle is actually the 30 degree and the 60 degrees. Again, if this is 1, and this is going to be 2, and this is going to be square root of 3. So we all know the sine 30 degrees is going to be 1/2, and the cosine is going to be square root of 3 over 2. All right, and 60 degree, of course, sine cosine is just just reverse sine 60 equal to cosine 30, and cosine 60 equal to 1/2. All right. Now, how do we figure out sine 15 degrees? Okay, one method is using the angle difference formula, which is this is a formula saying that the difference of two angles is actually can be expressed in terms of sine and cosine of individual angles alpha and beta. Now we plug in, like for example, 45 minus 30 would be 15, and we all know the value of 45 degrees and 30 degrees. So we plug in the value, we're going to get this multiplication, and then because square root of 2 and 3, that would be 6. That's the value. All right, so that's it. So we figured out from the value of 45 and 30. Now the cosine, we can figure out cosine 15 degree in a similar fashion. Plug in 45 and 30, we're going to get this, and then continue the process. The only thing here is a plus sign. All right. So let's move to the second method. We can use half angle formula. In this case, we just review that sine alpha. Sine half of alpha is equal to plus sine or minus, depending on the range of alpha. All right. So, So in that case, we say alpha equals 30 degrees, then we're gonna get a sine 15 degree results. All right. Let's plug it in. All right. So this is going to be 30 degree. Cosine is going to be square root of 3 over 2. You plug in, and then this looks like it's different from the previous result. All right. So previously you have square root of 6. We have this. All right. So but right now you have this one. Are they the same? It turns out that they're actually the same. We just do some trick here. You multiply 4 by both the denominator and the value here. That would be 16. That would be 8 minus 2 times square root of 12, and it happens to be this square. All right. So they're identical. All right. You can verify that by just expressing out the square. Do some algebra steps. You're gonna get this the same result. All right. So of course the cosine would have a similar fashion, and only thing here is the plus sign. Okay. So you go through the process, and similarly you can change to the identical form as in the previous method. All right. So this is the second method. We use a half angle formula of sine and cosine. Now there are actually more interesting method in figuring out sine 15 by some geometric methods. All right. So in this case, look at this triangle ABC. we have the angle. We assume that AB, right, equal AC, and equal to x, and this angle here is 30 degrees. All right. So what we do is we're going to draw a line AD, right, so that is perpendicular to BC. Similarly, we're going to draw a line BE, so that is perpendicular to AC. All right. So when you think about it, this is 30 degree and this is right angle, so this must be 60 degree. And then so this dividing the 30 degree angle, so alpha is going to be 15 degrees here. And this ABC is 75 degrees, right? The angle C is 75 degrees, and we're going to have 60 degrees here, so this is remaining one is 15 degrees. Okay, so we have 15 degrees here, 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 three angles. We mark it as alpha. Now from this construction, right, once we have this angle and then have this AD and BE line, and we know that AE, right, so AE is equal to x, right, AB times sine of 60, right, so x times sine of 60, right, that's going to be AE. All right. So in the meantime, we also know that BD in this case equal to x sine of alpha, which is sine of 15 degree. Let's call sine of 15 degree. Let's call it y. This is going to be BD is going to be x times y. All right. So where y equal sine 15 degrees. This is the value we try to figure it out. All right. So you notice that BD and DC are equal, right? So in the next step, you're going to see that these angles are over 15 degrees, right? Just refresh, this is the fact. But then what is the EC value? The EC here is going to be sine alpha times BC. What is BC? BC is actually twice of BD, all right? So BC times sine alpha, we know the sine alpha, we're going to equate y. And earlier we said that, this BD equal to x times sine alpha. So you have 2x sine alpha times sine alpha. In other words, we're going to have 2xy squared, right? But notice that the CE plus AE is going to equal to x, because 9 segment AC equals the sum of AE plus EC, where AE in the earlier result we figured out is equal to x times sine 60 degrees, all right, plus the EC, which is a value we figured out earlier, right, and they equal to x, right? So with this equation, you can cancel x, right? You can cancel x, and we also know the sine 60 degrees that we figured out earlier is a special angle, so it's the square root of 3 over 2. So we plug in the value and also cancel x. What we get is sine 60 degrees, which is square root of 3 over 2, plus 2, x, we cancel that. It's going to be 2y squared equal to 1. So from that equation, y, which is sine 15 degree, right, equals square root of something here, right? So y squared equal to 1 minus square root of 2 and then divide by 2. So I'm going to have this value. Remember earlier that we said this actually happens to if you times 4, and then you can try to put this into a square, okay? And this is the first similar transformation as earlier. Applying some algebraic operations, you're going to have y equal to square root of 6 minus square root of 2 over 4, which is identical from the earlier method. All right. So that's it. So we using this geometric method, we figured out sine 15 degrees. All right. Of course, and there's some other method also, for geometric constructions. One example, here is, this is 45 degrees, and this is 60 and 30 degrees special, and then we can construct another 45 degree angle. So here you got a 15, right? You got a right angle here, and you can find out sine 15 is equal to x divided by this number here is 2. All right. So we try to find out what is x. All right. So we're going to leave this as an exercise. Why don't you think about it and try to use this figure to figure out sine of 15 degrees. Of course, there's another one. I'm not going to explain the detailed steps and leave this as an exercise for you. All right. Okay. Thank you for watching the video, and I hope to produce some more kind of video on interesting topics. All right. You can reach me through my Gmail. All right. Thank you. Bye bye.